Students, good morning. And in last previous class, we are discussing about Planck's quantum theory. Very important concept, atomic structure chapter. And now today class, we just do some important problems, particularly in objective point of view in this chapter. Students, now let us start problems one by one. Now let me write first problem. Calculate energy of 1 mole of photons of radiation whose frequency is 5 into 10 power 14 Hz. This is the question. Sir, how are you ready to answer this question, sir? What formula we utilized here? Students, now let me come into the formula. We go for, once again, Planck's quantum theory, energy frequency relation. The formula going on here, energy E is equal to h nu, according to which theory, sir? Planck's quantum theory. Very important one. Planck's quantum theory. Students, he just asking about energy of 1 mole of photons whose radiation simply having frequency 5 into 10 power 14 Hz. First of all, we are ready to calculate energy of 1 photon. Are you got it? Energy of 1 photon. And then we go for energy of 1 mole photons. Okay, now, or if you are interested, we are ready to write the direct formula. What we have? Okay, energy of 1 mole of photons. Dear students, we know formula very well. E is equal to NH nu. What is N, sir? Dear students, here N is nothing but number of photons. Is it clear? But the question gives an idea. 1 mole of photons. Keep in mind. 1 mole of photons means what, sir? 1 mole of photons means Avogadro number of protons 6.023 into 10 power 23 number of photons, dear students. Okay. And we know H value in joule second 6.625 into 10 power minus 34 joule second. And frequency is already given 5 into 10 power 14 Hz. Hz, or we may also call second meters. If we substitute all these values, we are ready to calculate energy of 1 mole of photons. Simply N value 1 mole means 6.023 into 10 power 23, and the Planck's constant H value 6.625 into 10 power minus 34 joule second, students, into frequency 5 into 10 power 14 second inverse. This is joule second. Keep in mind. Okay. And second inverse, second mutually cancel. We get final answer in what, Nana? Simply joules. Okay, now. So we just look at how the problem is going on, dear students. Okay, we just do your calculations. Rough calculations aina parledu. మీరు ఒకసారి మీ క్యాలిక్యులేషన్స్ మీరు ఒకసారి చూడగలిగితే క్లారిటీగా మనకు ఆన్సర్ తెలుస్తుంది. ఇది 10 పవర్ 14, 10 పవర్ 23 కదా, అంటే 10 పవర్ 37 కదా నాన్న. అంటే మిగిలింది ఎంతరా ఇంకా 10 పవర్ 3 మిగిలిందిరా పిల్లలు అవునా మనం వీటిని కనుక మల్టిప్లై చేస్తే dear students we get almost 199 something and that's why students energy of 1 mole of photons 199 10 power 3 into joules ante we directly write kilojoules dear students 1000 kada 1000 joules ante kilojoule kadra nana so almost 199 kilojoules dear students so this is one type of problem very important one in examination point of view students and now let me coming to another important problem another important model the question going on here compare dear students compare the energies of two radiations the one is dear students violet color radiation having wavelength dear students 400 nanometers and red color radiation dear students red color radiation having wavelength 750 nanometers. Sir, are you ready to answer this question, sir? How it is possible? Students, while we coming to once again the formula what is going on here energies means we know already energy E is equal to H in nu. Keep in mind what is nu, sir? Dear students, simply Hc by lambda. Here H is Planck's constant dear students and C is velocity of light. Both are constants. H comma C both are constants dear students and that's why E is inversely proportional to 1 by lambda. Is it clear? So E is inversely proportional to 1 by lambda means dear students E1 by E2 is absolutely lambda 2 by lambda 1. Okay, and now we are ready to calculate energy of violet color radiation versus energy of red color radiation. Means what, sir? Inverse kada ante wavelength of red color radiation by wavelength of violet color radiation dear students. Is it clear? So enta sir red color radiation dear students. Now let me write here nana. Let me write here. I have no space here. So E violet color by energy of red color radiation simply I think 750 kada wavelength of red color by dear students 400 violet color wavelength dear students. Is it clear? So I think 75 by 40. Is it right? So fifth table 15 by 8 nana. That's why the ratio of violet color radiation energy versus red color radiation is simply 15:8 dear students. Very important one in objective point of view. Keep in mind dear students. Students, next problem very important model in objective point of view. The problem going on 100 dear students 100-watt bulb, please observe this one, emits a light of wavelength dear students wavelength 400 nanometers And the question is, would you please calculate the number of photons, dear students, emitted by the bulb? Is it clear? He's simply asking about the number of photons emitted by the bulb. And once again, students, when we come into our formula, energy of emitted light radiation is absolutely equals to N into H into nu. But we have wavelength, keep in mind. And that's why energy of emitted light radiation is simply N into H into C by lambda. Because nu, frequency, nothing but C by lambda. Is it clear? So in the entire question, we are ready to calculate number of photons here. So we are ready to find what, man? N. N represent what, sir? Number of photons, dear students. But he just given that bulb emits, dear students, a light of a monochromatic one which is having power 100 watts. So students, power of bulb, most important one, power of bulb, what it is, sir? 100 watts, keep in mind. Okay. And students, now let me coming to 1 watt means what, sir? Here students, 1 watt is nothing but 1 joule per second. Means what, you know? In 1 second, dear students, in 1 second, the bulb emits, dear students, 100 joules of energy. Keep in mind. So this is a very, very important aspect. So then we have got an idea what is energy of the bulb emits, sir. Energy of the bulb emits here 100 joules. So that's why the emitted light having energy 100 joules. Keep in mind. Because the question is also calculate number of photons emitted by the bulb per 1 second. Yes, students, per 1 second. It's the continuation of the question. Okay, second lo, any number of photons emit outai, ade calculate cheyamannadu manallu. So we already know what is lambda here, sir, 400 nanometers. Joule is SI unit, and that's why nanometer converts into meters. Okay, 400 into 10 power minus 9 meters. 1 nanometer means 10 power minus 9 meters. And we know velocity of light in SI units 3 into 10 power 8 meters per second, dear students. And if we substitute all the values here, E means 100 joules, dear students. And what about N, sir? We are ready to calculate this value. What about H, sir? Planck's constant 6.625 into 10 power minus 34 joule second into C, velocity of light, means 3 into 10 power 8 meters per second by, what about lambda, sir? Dear students, this is 400 into 10 power minus 9 meters. Is it clear? So, if you solve this, dear students, just look at 400 di pakkaki తీసుకొద్దాం. 4 into 10 power 4 into 10 power minus 9 by, what about this one, sir? Multiplied 6.62 into 3, 8.19, I think it is, okay, into 10 power, dear students, minus 26. So if we go for the rest of calculations, dear students, and we found an answer, dear students, 2.01 into 10 power 20 almost, dear students, photons emitted per second. Photons emitted per second. Very important one, dear students. A watt ante ento definition clarity undali manaki. ఓకేనా? వాట్ అంటే ఏంటో డెఫినేషన్ క్లారిటీ ఉంటే మనం ఈజీగా ఆ ప్రాబ్లమ్ని ఆన్సర్ చేసే ప్రయత్నం చేయొచ్చు. వెరీ ఇంపార్టెంట్ అన్న, వెరీ ఇంపార్టెంట్. Now let me coming to another important mode. The question going on, find the, dear students, find the wavelength of an electromagnetic wave and electromagnetic wave of one quantum energy, wait, not one quantum energy, wave, one quantum which contains, dear students, which contains 4 electron volts energy. Wave of one quantum, that's it. And each quantum having energy 4 electron volts. That's the thing going on here. Okay now, so what he is asking us, sir, is simply asking us, dear students, wavelength of that electromagnetic wave. But students, while we coming to answer, we are very careful to look at the units of energy of emitted radiation. What are units, man? Electron volts. So that's why, dear students, in my previous class, Einstein approach, energy in electron volts, we have formula 1242 by lambda in nanometers. Are you remember? You just look at my previous video. We have this formula 1242 by lambda in nanometers. So what is lambda in a nanometers, sir? Simply 1242 by energy in electron volts. So lambda in nanometers, dear students, 1242 by energy 4 electron volts. And that's why, dear students, what is lambda in nanometers are 3, I think it is. This is 1. Am I right, Nanda? Okay. And whatever the rest of are, I think 0.5. So that's why lambda in nanometers simply 310.5 nanometers. Dear students, very important one in examination point. Most important one. Students, and now let's come into the previous JEE mains question. A bulb of 40 watts producing, dear students, producing a light of wavelength 620 nanometers with 80% efficiency. Underline that word, 80% efficiency. Then the number of photons, dear students, emitted by the bulb in 20 seconds, or this is the question. Students, we have different options here. 2 into 10 power 28, 2 into 10 power 21, only 10 power 21 and only 10 power 18. Different question from 2019 main session in this atomic structure chapter. So, students, while we coming to one thing here, now let me coming to once again power of bulb. Please observe that one. Power of bulb. We know power of bulb which is 40 watts. We already know 1 watt means what, sir? 1 watt means 1 joule per second. Is it clear? So means that bulb in 1 second, dear students, that bulb emits 40 joules energy. Keep in mind. Okay, now, so in 1 second, the light which is coming from the bulb possesses energy 40 joules. But the question demands us calculate how many number of photons emitted out from the bulb in 20 seconds. Not per 1 second, 20 seconds. So, in 1 second, bulb emits 40 joules energy. What about for 20 seconds, sir? Within time of 20 seconds, it emits what energy, sir? Okay, so simply, dear students, the energy emitted by the light bulb is simply that 40 into 20, dear students. So energy of the light coming from the bulb is absolutely 800 joules. Keep in mind. Very important one. Per 1 second 40 joules. For 20 seconds what, sir? For 20 seconds 20 into 40, 800 joules. Students, but the thing is, the bulb is only 80% efficiency. Keep in mind, not 100% efficiency. So, 20% of the emitted light is not at all considered as it's a fulfilled energy. 20% energy waste. Only 80% efficiency given by the bulb. So, dear students, total energy of light emitted by bulb. Yes, students, emitted by bulb. What it is, sir? Total energy, of course, 800 joules, but bulb only 80% efficiency means 80% means by 100. Is it clear, students? Means what, sir? Here, two zeros cancel. 8 into 80, 640 joules energy emitted out by the bulb. That's what we call 80% efficiency. Remaining 20% waste. Students, are you got it? Okay. And then we are ready to write our noun formula. E is equal to, dear students, NH nu. Means E is equal to NHC by lambda. And students, what is energy now? 640 joules energy. Is it clear? What is N sir? We are ready to calculate number of photons. What is H sir? 6.625 into 10 power minus 34 joule second. Into what is C sir? Velocity of light 3 into 10 power 8 meters per second. By what is lambda sir? Is already given wavelength 620 nanometers, means 620 into 1 nanometer means 10 power minus 9 meters. Students, is it clear? So we go for calculation. Dear students, 640 into 620 into 10 power minus 9 by 6.62 into 10 power minus 34, 3 into 10 power 8. Yes, students. So upon calculation, finally we get value almost 2 into 10 power 21. Almost 2 into 10 power 21. Number of photons, dear students, emitted per 20 seconds by the bulb. Very important one, students, this model. That's why it becomes a mains objective question. Keep in mind, Just look at the strength of question here, students. Very students, and also I am coming to 2018 NEET question. Very important one. Just look at a body, dear students, absorbs an electromagnetic wave of wavelength lambda is equal to 500 nanometers. If it releases all the energy absorbed by emitting, dear students, by emitting two wavelengths, one of which, dear students, 800 nanometers. Would you please calculate the wavelength of, dear students, the wavelength of other wave which is emitted? Previous NEET question. While we coming to different options, students, here the one is 300 nanometers and another one is 1333 nanometers, and the third one 1300 nanometers, and the fourth one, dear students, 800 nanometers. This is the question. Sir, how can you answer this question, sir? Students, we know one thing. A body what absorbs the total amount of energy is absolutely emitted out. Means that is a black body. Keep in mind. Okay now. But the emission takes place with the help of two different radiations. Just look at, this is a black body. Students, this is a black body. Some light of radiation having energy, some E is incident into it. Of course, it is absorbed. Okay. And then after absorption, the total energy emitted out in two different type of radiations, 1 and 2. Are you got it? Okay. So the wavelength of one of the radiation, what is going on? 800 nanometers. Keep in mind. Would you please calculate the wavelength of another radiation emitted out? This is the question. And moreover, dear students, the emitted light having wavelength 500 nanometers, keep in mind. Initially, the incident light radiation having wavelength 500 nanometers, and after emission, two different radiations are coming out. One is having wavelength 800. What about the rest of one? This is the question. So the thing is, students, total energy absorbed is further emitted out. మొత్తం ఎనర్జీ ఎంతైతే అబ్జార్బ్ చేసుకుందో అది మొత్తం అంతా కూడా ఎమిట్ చేసేసింది. సో టోటల్ ఎనర్జీని మనం E అనుకుందాం. ఓకేనా? అంటే ఇన్సిడెంట్ ఎనర్జీ లేదా దీన్నే మనం అబ్జార్బ్డ్ ఎనర్జీ అనొచ్చు. is absolutely equals to, dear students, emitted energy. So absorbed energy is absolutely equals to emitted energy, but emission takes place with the help of two different radiations, and that's why this is the energy of first radiation and this is the energy of second radiation, dear students. We have formula for energy hc by lambda, and we have formula for energy hc by lambda 1, and we have formula for energy hc by lambda 2 according to Planck's quantum theory. But here h and c always constant, so they are cancelled together, and that's why 1 by lambda is equal to, dear students, 1 by lambda 1 plus 1 by lambda 2. Keep in mind. Okay, is it clear? And that's why, students, while we come to our calculation part, What is lambdas are initially incident light wavelength, means 1 by 500 is equal to 1 by, say this is lambda 1, say this is lambda 2. One of the emitted light radiation having wavelength 800 nanometers, keep in mind. What about the another emitted light radiation wavelength to sun? That is the question. While we coming to 1 by lambda 2, dear students, 1 by 500, ఈ టర్మ్ ని పట్టుకొద్దాం నాన్న, minus 1 by 800. Am I right? 1 by lambda 2, dear students, just look at LCM. 800 minus 500 means 300 by 500 into 800. Mathematics LCM నాన్న, దీన్ని కూడా ఇంకా నేను సింప్లిఫై చేసి చెప్తే వరస్ట్ గా ఉంటుంది. ఓకేనా? So dear students, just reverse these terms. Then lambda 2 is equal to 500 into 800 by 300, dear students. Is it clear? And 2 zeros cancel here. Okay. And what about this one, sir? 4000 almost by 3. 4000 by 3 means what, sir? 1 3 3 3 so on. And that's why, dear students, the wavelength of other radiation emitted out is absolutely 1333 nanometers, dear students. And these are all previous objective questions on the concept of photo, means Plancks quantum theory. Students, very important concept, black body radiation, and another one is Plancks quantum theory. Students, in my next class, I am ready to explain another most important topic, photoelectric effect. Just awaiting for my today class. Okay, we're all awaiting for my today class, and this is today class. Okay, and tomorrow session I bring some more important topic, photoelectric effect, dear students. ఈ ప్రాబ్లమ్స్ అనే నీట్గా నోట్స్లో రాయండి, మీకు అర్థమైనయో చూడండి ఒకసారి, ఏనన్నా జాగ్రత్తగా నోట్స్లో రాసుకోండి, క్లాస్ మిస్ అవ్వకుండా. మనం నెక్స్ట్ క్లాస్లో ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అన్న కాన్సెప్ట్ని చూద్దాం. థ్యాంక్ యూ స్టూడెంట్స్, థ్యాంక్ యూ చిన్న ఎవ్రీవన్, బాయ్.